This is 7.3, multiplying polynomials, but it's special cases. So let's look at the first one. So here I have a plus b, but notice it's in parentheses, and all of that parenthesis is being squared. Well, a lot of times we forget the common, what an exponent really means. Remember if I had like, if I had like 4 squared, and what that really means is 4 times 4, or 8 squared, that's 8 times 8. So it really means to repeat, repeat the, the base or whatever it's referring to. And so that's why it's being repeated. So we literally write a plus b and a plus b twice. And then we're going to FOIL that. We're going to multiply it. Now, a common mistake is a lot of students sometimes when they see this problem is they'll just they'll think it means like this. And remember how to do exponents there is, it's sort of, a lot of students think it's like the distributive property and they'll write a squared b squared, which this is correct. That's how you do that. But remember that rule only applies if that's multiplication, not with addition. So a lot of students, when they see this problem here, they'll make that same mistake and they'll think it's a squared plus b squared. You cannot do the exponents, multiply those exponents with a plus sign here or a minus sign. It only works with multiplication. So just keep that in mind. All right, so what you do is repeat it just like what we did, and then what we're going to do is just FOIL it like what we did the previous lesson. So a times a is a squared, and then a times b is ab, and then come back and use the distributive property again. So b times a, which is ba or ab. Remember, the order does not make a difference on multiplication. And then b times b is b squared. And I want you to notice something very important here. The two middle terms are identical. Because you notice what we did is we took this parenthesis and we repeated it. So these two middle terms are going to be added together to be 2ab. And that's something I want you to notice when you are doing this multiplication here. And this is the square of a binomial. So here you have a binomial and you're squaring it. So notice whatever, this first one's going to be, the first number, this first number squared. And notice this last number is going to be the last number squared. But the middle term is basically taking the a times b, and then you're going to double it. And so really that's what I want you to notice, that anytime you can literally go straight from here to here, you don't have to literally write it out and then FOIL it. You can do that. You can write it out twice and FOIL it, but this is a quick way to get to the answer whenever you're doing that. So for instance, like this, we could, if we wanted to, we could write it out twice. 5x minus 3 and 5x minus 3, and then FOIL it out. But what we just now learned is you're going to take, remember what that, it's a squared plus 2ab plus b squared. So you take this first term and you square it. You take the last term and you square it. And then the middle is going to be 2ab. So basically 2 times the 5x times the negative 3. And so this is going to be 25x squared. I'm going to change it to a minus. You can put plus negative if you want, but negative 30x and then plus 9. So a lot of times, that's why it's called special cases. You can FOIL this, okay, and you'll still end up with this answer, okay? But a lot of times what you can do is you can pretty much, if you know this, you can pretty much get to the answer probably a little bit quicker, okay? So let's try it again. Again, you can write this out twice, 4x plus 1, 4x plus 1, and then FOIL it. You can do that. But remember what we're going to do is what we're basically going to fill in. This is your a, your first term, so that would go there and here. And this is your b, so it would go here and there. And then you just evaluate that. So that's 16x squared, that's 8x, and that's 1. So it's a little bit quicker if you get used to the pattern instead of just foiling it out. Again, there's nothing wrong with foiling it out, nothing at all. But again, if you get used to this pattern, it is a little bit quicker to be able to do that. So let's look at another special case. So we just got done talking about like what if it was a binomial being squared, but here what we have is a binomial and it's another binomial, but notice they're not being squared. I have one of them being a plus b and the other one being a minus b. So if we FOIL this, a times a, that's a squared, and a times negative b is minus ab, and then come back and multiply this, and that's b times a, or ab. Remember, the order does not make a difference. And then negative b squared. And again, I want you to notice the two middle terms. What happens with the two middle terms? I have negative ab and I have positive ab. They're going to literally cross each other out. So this is special case number 2. Whenever you have, this is called the difference of squares. So you have like a plus b and a minus b. So it looks like the same parenthesis. It looks like the same exact parenthesis, but one's a plus and one's a minus. So you're going to end up with the middle term crossing out. And so basically it's just going to be the first term squared minus the second term squared. So let's look at it. So notice I have 2x minus 3, 2x plus 3. So again, we could FOIL it out. All right, but you will see that the middle terms will cross out. That's why it's called a special case. So if you know the special case, what you could do is just simply multiply the first one. You're squaring the first one, 2x times 2x, 4x squared, and then you're squaring the next one. And again, it's called the difference of squares. So it's always 4x squared minus 9. All right, so the same thing here. We're going to take the first one and the second one, square them both. See, x squared, 8 squared, but then it's going to be the difference of squares. All right, we're going to take the first one and the second one. We're going to square them. It's going to be the difference. Again, you can FOIL it if you want, okay? But you will see whenever this is 4x minus 5, 4x plus 5, x plus 8, x minus 8. Whenever they're opposites like that, the middle term will cross out. And again, let's take it to another level. Let's look at this scenario. What if I had a rectangle or some shape like this, but I have a rectangle inside of a rectangle, and I want to find out the area of just the yellow, And what I want you to notice is I have a square inside of a square, and you're like, how'd you know that? Well, notice this side is 2x plus 4, this side is 2x plus 4, so that means the big square is the exact same measurement, so I know it is a square. And then notice the green box, I have 2x plus 1 and then 2x plus 1, so I know it's another square that's inside of the other square. So what I'm going to do is, there's a couple ways to do this. But one of the ways I want you to notice is, like, it's literally a square inside of a square. So if I took the middle square out, okay, so if I found the area of this big square, and then I took the area of this little square, and I'm going to find them both. And really what I'm doing is I'm not trying to find this whole area here. I'm just trying to find, if you remember, I'm just trying to find, if I take this little box here, this green black, the green border, but it's a black box. If I put that in there, it means I'm cutting that part out. So I'm literally just like cutting this out of here. See, I only want the edges. Okay, so I only want this part right here. And so that's what I'm going to do is I'm going to literally take the big box and then subtract it from the other box. So let's look at it. So this box is literally, remember how to find the area of a square, a rectangle, you take length times width. So it's 2x plus 4, and it's being squared. So remember, what we're going to do is just basically, let me do it the exact same way what we did a minute ago. It's this. And so the A goes in here. That's the A. And then the B goes in there. And then what we're going to do is just simplify this. That's 4x squared. So this is the area of this box right here, of that square. Now we're going to do the exact same thing over here. We're going to find, take 2x plus 1 squared. And so 2x goes in here. Then 1 goes in there. So this is going to give us 4x squared plus 4x plus 1. So this is the area of this box right here, of this square. But remember, what you have to do is keep in mind, if we put that box back, it would look like this. And so we're literally cutting this out of the big one. That's why we're subtracting them. Because all we want to do, if I can switch to a highlighter, let me see if that'll look good. If I switch to, let's see if I can switch to white here. So what I'm trying to do is find this area right here. So that's how come I know it's a subtraction problem. I'm literally taking this area right here and I'm taking it away from the big area. So I'm going to literally just do a subtraction of the polynomials, 4x squared plus 16x plus 16, and I'm going to subtract 4x squared plus 4x plus 1. And so I'm going to literally subtract. So keep in mind, I'm literally subtracting each column. So 4x squared minus 4x squared, they cross each other out. 16 minus 4, x is 12x, and then 16 minus 1 is 15. So this right here is the shaded white area right here, this thing right here. That's the area of what I'm trying to find left over the area. And whatever x is, x could be 3. If I said now if x is 3, then you would substitute 3 in right there and actually get a numeric value or something like that. And believe it or not, this in life, this can, like if you were carpeting a living room space and you only had to carpet this area right here. If you only had to carpet, like you have something there, whatever it is, and you only had to carpet this, then you'd have to find out how much square footage it is. And so this would be the square footage that you would have to purchase of the carpet. And let's just say carpet is, I don't know how much carpet is, but let's say it's $3 a square foot. Then you can simply multiply that in and find the cost of carpeting or something, or tiling something. Tile is, some tile is about $2 or $3, $5, $10 each, depending on what type of tile you buy. But, so that would be a very good scenario of buying something for using this as a scenario in real life to be able to do this. So that's how you use special cases of multiplying polynomials.